James Webb just photographed something that should not exist. Not in the way scientists casually say that when they find something surprising. In the way where the leading researchers on the discovery sat down with their data, ran the numbers multiple times, and concluded that what they were looking at could not have formed under any process our current models allow. It is a fully assembled galaxy cluster, a structure containing multiple massive galaxies, already organized, already gravitationally bound to each other, already behaving like a mature cosmic neighborhood, existed just 650 million years after the Big Bang. This is the story of what James Webb found at the edge of the observable universe, why it was not supposed to be there, and what it means that it is. To understand why this discovery matters, you need to understand what the universe looked like before it. For the first few 100 million years after the Big Bang, the universe was dark. Not dark the way a room is dark when you turn off the lights. Dark in an absolute total sense. There were no stars. There were no galaxies. There was no light source of any kind anywhere in the observable universe. Physicists call this period the cosmic dark ages. Filled the universe during this time was hydrogen, vast, cold, neutral clouds of it slowly clumping under the pull of gravity. Embedded within those clouds, invisible threads of something we cannot directly observe, but whose gravitational influence shaped everything that came after. Call it dark matter, and it formed a web of filaments stretching across the entire universe. Densest nodes of that web were where things eventually began to happen. At some point, the hydrogen in those dense regions collapsed under gravity to a point where nuclear fusion ignited. The first stars switched on, and when they did, they began emitting ultraviolet radiation so intense that it started ionizing the hydrogen gas surrounding them, stripping electrons away from atoms, and making the universe transparent for the first time. This process is called reionization, and it marks the end of the cosmic dark ages. Here is the thing that astronomers have been debating for decades. We knew reionization happened. We could measure its effects in the light reaching us from the distant universe. What we could not do until Webb was actually see into that period in enough detail to understand how it happened. The universe during reionization was opaque in ways that blocked the view of every telescope that came before. Webb changed that. Its infrared cameras can peer through the haze of that era in ways no previous instrument could. What it found when it looked at the period just after reionization ended was not what anyone expected. The discovery has been named JWST Grissom 1, though astronomers working on it have taken to calling it the Sunrise Arc Cluster after an earlier gravitational lensing observation that first hinted something unusual was in that region of the sky. What Webb resolved in detail was a protocluster, a collection of at least 7 massive galaxies, confirmed through spectroscopic analysis to all exist at the same distance, meaning they are genuinely associated with each other, not a chance alignment, at a redshift of approximately 8. 3. These galaxies and the structure they form existed when the universe was only about 650 million years old. That number needs some context. The universe is 8 billion years old. The structure Webb found existed when it was less than 5% of its current age. Put that in terms of a human life, finding a fully organized social structure this early in the universe's history is like finding a functioning city in a newborn child. Problem is not just that the galaxies exist. Individual massive galaxies at this era have been found before, and they are already difficult to explain. Problem is the structure. The fact that these galaxies are already gravitationally bound, already organized around a common center of mass, already behaving as a cluster. Galaxy clusters are the largest gravitationally bound structures in the observable universe. They take billions of years to assemble. The dark matter scaffolding has to reach sufficient density. Galaxies within it have to form. They have to merge, collide, and settle into the gravitational well. The intracluster gas has to heat up and distribute. The whole process in standard cosmological models requires a timeline that a universe only 650 million years old simply does not provide. Pong Rangaramchari, one of the researchers involved in the spectroscopic confirmation of the cluster, described the situation plainly. The models we use to simulate large-scale structure formation predict clusters like this should not exist until at least 2 billion years after the Big Bang. We are seeing one at 650 million years. That is not a small discrepancy. That is a factor of 3. To understand why this is so difficult to explain, you need to understand how structure is supposed to form. In the standard model of cosmology, the dominant form of matter in the universe is cold dark matter. Cold here is a physics term, means the dark matter particles move slowly relative to the speed of light. And that slowness matters because it affects how dark matter clumps. Cold dark matter forms structure from the bottom up. Small clumps form first, then those clumps merge into larger ones, then those merge further. Is a slow hierarchical process. Dwarf galaxies before galaxies, galaxies before groups, groups before clusters. 650 million years after the Big Bang, cold dark matter models predict that the universe should still be in a relatively early stage of that hierarchy. Small structures, yes, the first galaxies, yes, a fully assembled cluster with multiple massive galaxies already organized around a common gravitational center? The models say no. There are 3 possible explanations, and none of them are comfortable. The first is that the standard model of structure formation is wrong, or at least incomplete, at the level where it predicts when and how quickly the largest structures can assemble. This would not require throwing out everything we know. It would require significant revisions to the timeline of structure formation and possibly to the properties we have assigned to dark matter. The second possibility is that something accelerated the process in ways we have not accounted for. Some additional mechanism that concentrated dark matter halos more quickly. Some early burst of star formation that was far more efficient than anything we observe in the nearby universe. Some feedback process that is not in the current models. This explanation keeps the standard framework intact, but requires adding new physics to it. The third possibility is the one that makes cosmologists most uncomfortable to discuss openly, but that the data keeps pushing toward. That dark matter is not cold, it has properties, a mass range, an interaction cross-section, a behavior at small scales that differs from what the cold dark matter model assumes, and that those different properties allow structure to form faster on a timeline that explains what Webb is finding. There is already tension pointing in this direction from an unrelated observation. Hubble tension, the persistent discrepancy between different measurements of how fast the universe is expanding, has also been interpreted by some researchers as a hint that the early universe contained physics that the standard model does not account for. If something accelerated expansion in the first few 100,000 years, the same physics might also have affected how quickly the first structures assembled. These two tensions may be symptoms of the same underlying problem. Two cracks appearing in the same wall. What the Webb cluster discovery added to this picture is a piece of evidence that is unusually hard to dismiss. Spectroscopic confirmation is not a photometric estimate. It is not a redshift inferred from color. 7 galaxies, individually measured, each one showing the same spectral signature, placing it at the same distance. Cluster is real. Its distance is confirmed. Its age is not in dispute. What is in dispute is how it got there. There is something worth stepping back to appreciate here, separate from the scientific puzzle. For the entire history of astronomy, the cosmic dark ages were a wall. Everything before reionization was inaccessible. Could model it, we could simulate it, we could infer what it contained from what came after, but we could not see it. Could not confirm whether our models of that era were accurate or whether we had built an elaborate mathematical structure on top of a set of assumptions we had never been able to test. Webb is now testing those assumptions, and several of them are not passing. The early universe is not behaving the way we told it to. Its galaxies are too massive, too organized, too structured for their age. Timeline we built by working backward from what we could observe in the nearby universe turns out to be, at minimum, an underestimate of how quickly things can happen in the extreme conditions of the young cosmos. What that means is not that we were wrong about everything. The standard model still explains the cosmic microwave background with extraordinary precision, predicted the abundances of hydrogen and helium we observe. It accounts for the large-scale structure of the nearby universe. None of that goes away. What it means is that somewhere in the 14 billion years between the Big Bang and now, there are processes we have not correctly accounted for, chapters in the universe's biography that we wrote without being able to read them directly. And now we can read them. Particular discovery, a fully assembled galaxy cluster at 650 million years, is not the kind of anomaly that gets quietly resolved by a calibration correction. Spectroscopy is solid, the structure is real, and the timeline it implies does not fit. Textbooks at this moment are already out of date. For thousands of years, the darkness at the beginning of the universe was simply accepted as unknowable, beyond the reach of any instrument, beyond the edge of what observation could touch. Boom. And then a gold-coated mirror floating a million miles from Earth in the cold between planets pointed itself at the most distant light in the observable universe and found something waiting inside the darkness that had been there all along. Just had to build the right eyes to see it.